All right, so hi everybody. I hope you guys are having a great Saturday. I presented this at Summit last year, so we're going to be talking about the future of containers. And my name is Marsha Pierce. I am the Principal Database Solutions Architect at Pure Storage. If you guys have any questions, please feel free to post them. They will be looking at them and we will answer them as they come in. You don't have to silence your phones because everybody's automatically silenced, but be aware of all the things that go on at PATH, like all the virtual meetings that they are doing. She kind of already talked about that, but might be a great time to help volunteer to run some of these events. It takes a little bit of work to get them on, but nothing else, maybe we can learn something while we're sitting at home. So again, if you want to follow me on Twitter, I'm at Marsha Pierce DBA, and I also have a blog, marshapiercedba.com. And I always kind of put this in my tagline. It's true. I drove a lot of storage admins crazy for a whole lot of years, and I broke a lot of stuff. And that's kind of how I ended up at Pure. I drove storage admins crazy too. They all knew who I was. So this is basically what we're going to cover a little bit about the basics of about containers, container basics, and then we're going to kind of show some orchestration. So I like to kind of show this if you haven't really started looking at containers yet. I've been in IT for a long time. So in the past, sorry, I'm pulling some work and hopefully try to see questions. We would do these huge projects where we would try and do a deployment, usually like a large project, maybe an ERP. And these were usually 5-year projects, right? And we would spend even a year scoping out our hardware and maybe even an entire year just implementing that hardware. But we did expect that hardware to be in the data center between 5 and 10 years. So they weren't very agile, right? They didn't flex a lot. You did a lot of sizing, trying to figure out how much you were going to grow and what was going to happen, and you hope you got it right because it was a lot of money and budget and everything was not very flexible. And then along came around, I want to say around about 2004, we started looking at virtualization, right? And virtualization was better. It was quicker to deploy. It still wasn't, super fast. It is very easy to spin up a VM. In and of itself, but when you talk about all of the different coordination between the groups and you're the SQL Server DBA trying to get enough resources and the compute and RAM and everything that you need and to actually get that server built, it still takes weeks, right? At a midpoint, in the last part of my career, I was really, when I was on Premises DBA, we were really building on-prem cloud solutions. And it was also very complex. We spent a lot of time, a whole lot of time, scripting out and automating these builds of these VMs to try and speed them up because they took so long. So we looked at everything from like creating templates with pre-installed and patched SQL Server VMs, right? That somebody with responsibility to keep up to date so that we made sure everything was deployed from the same VM, to scripting out and automating our installs with things like UCS Director or vRealize Orchestrator or Jenkins or something like that. And now when you look at like how easy containers are deployed, it's kind of changing the game because instead of taking, really, weeks to get that like SQL Server like template standardized, it only takes a few minutes really kind of to set up. And then it takes just seconds to deploy. And then, with that's progressing on into microservices. So where those will live up and down for just a few seconds. And if you think about what microservices are, think about maybe, we're talking about containerizing maybe databases, but think about some of the things that you do that maybe you don't want to live around taking up a lot of resources all the time. Maybe you have ETL services, right? There's something that periodically goes and gets data. Some of those jobs, people are looking at spinning up those types of activities into microservices where they just come up, consume some resources, and then spin down, because ETL, I think, servers are a good example of that. They are usually inactive most of the time. They do most of their work after hours. They may do some stuff during the day. Most companies don't do that. And it's very, so maybe having things that spin up and spin down can get you better overall utilization of your compute stack. And when you think, how are containers different than virtualized environments? How they really are different. They both have the common server environment. They both have the common host OS environment. But when you look at like how a container differs from a VM, when you have VMs, every VM is basically a whole virtualized machine where you have to have the guest OS and then you install the application. With a container, you are virtualizing the application. And also, you're kind of going back to some old school technology where we're using some Linux functionality to segment out resources. And so they're kind of just aligning that at the Linux layer. But you were doing all of that with VMs at the hypervisor layer. And those can be complex to troubleshoot. I think we've all hopefully attended some VMware optimization classes. I spent a lot of time talking about VMware optimization, but a lot of things can get stuck at the hypervisor. And when you talk about patching and the complexity of all of those guest OSs, right, there's always been a debate. Should I have a VM for every database? Maybe bigger VMs are better because maintaining lots of little database and host servers, that becomes complex too, right? They all have to go down for Windows patching. So when you get rid of that whole, you separate the application layer from the guest OS layer, and now that application is kind of virtualized, it can move around. You don't really care anymore what hardware it's running on, what guest OS it's running, what your patching cycle is, because you're going to do some of that failover and stuff at the application layer, right? And so, this is something we had pulled together at my company. Why are containers important? Because you are decoupling application runtime from infrastructure, right? They do run instantly. We'll look at that in a second. It is just seconds to populate a VM. And then we get into this concept maybe of never really patching SQL Server again, but maybe constantly redeploying new versions of SQL Server, right? So the whole patching concept goes away. And then again, like we talked about, there's a building block for microservices to kind of modernize your apps. And microservices are great, right? Because then you're building a service to do one thing, right? And that's easier to troubleshoot that one service when you get rid of all of its downstream dependencies, and it's really just running within itself, doing what it needs, and then it goes away. It's going into that smaller, more agile, localized changes that you can troubleshoot more quickly and roll out just a little bit at a time. And then when you think about, sorry, did not mean to do that. Let's go back. Why are containers important in the SQL Server world? Because containers have been out for a while. They're not new, but they're newer to the database world. And database people seem to always be the last in. I talk to shops all the time that tell me they're 100% virtualized, and then I find out they still have bare metal SQL servers. But containers are coming for databases, and Microsoft rolled out last year. They announced at Ignite big data clusters, and that requires that you use containers in order to run a big data cluster, right? And I did this the last time I talked about this, but they use Polybase, as I was blanking on the name, Polybase, to spin out and push down queries to the server. So think about big data clusters. It's the idea of being able to kind of do some data virtualization, right? So you will have a SQL server, and it can query data in place, and it has some native drivers, and those are Polybase, and they're containerized, and they will talk to maybe an Oracle environment, maybe to a Snowflake environment, a MySQL environment, or other SQL Server environments. But unlike link servers, which would run the query natively on the SQL Server that was requesting the data, it would go to the other server, right, your target server, request all the data. That would bring in the entire data set back, and then all your logic, all your where statements were applied afterwards. And those were like horrible performance, right? Terrible. They didn't scale very well. And so you had to really think about how you were going to implement link servers, right? Maybe only use remote procedure calls or something when you were going to do that. Well, so big data clusters is the next advancement of that, because it's actually pushing that query down to the target server and only returning the result set. And then you have the option to restore that result set back on your big data cluster. So it's kind of eliminating a lot of the need maybe to do things like ETL, maybe to be able to query data across disparate systems in place. So I think that's very interesting, but that requires you run containers. And when you look at CI/CD pipelines, right, that's really become big, and it's something that I've spent a lot of time in my career building the last, God, I'm thinking about it now, like 14 years. I worked in continuous integration shops. And I can tell you, implementing continuous integration, when you include the database into continuous integration, which I don't think a lot of people do in their continuous integration environments, it becomes a game changer, because there's a lot of bad code that goes out. There's a lot of performance issues that we as DBA spend time troubleshooting because they did not hit those errors early enough in their environment. So being able to containerize databases and implement these CI/CD pipelines is really meaningful, right? When I was working in CI/CD shops, one of the problems that we could never get around was that we had, when we were doing these, we had a UAT environment that was actually refreshed using some storage technology before every code push, right? So we did this like 50 times a day. So we were always testing against that. And then we had QA that we would do, and UAT every once in a while. We had a development system that maybe once or twice a week, right? QA more frequently than that. But what we always wanted to get to, which is the goal in a CI/CD shop, is to have every developer have their own sets of VMs, right? So they had their own data sets, so they could work on their own branches of code, right? They're working on different projects, and some of them are overlapping on the same database functionality, and that causes branching issues. So if we could give every developer their own set of environment to do regression testing, we would be more effective at what we could do. But we could never get there, because when we look at the cost perspective from twofold, one, from just the VM cost for giving every developer a copy of the production environment, it was just cost prohibitive. And then the copies of storage of the databases and trying to figure out how to give them those data sets, that was also cost prohibitive. But technology has changed. And actually the shop that I used to work at is now leveraging containers, right? That was one of the first CI/CD shops I knew of. When I heard about some of the technologies that were coming out with containers, I reached out to the team. They were already looking containers. They hadn't containerized their databases, and now they are. So people are starting to do this, and they actually spin up about 16,000, I want to say, containers a day, up and down. And this is all, it's a large bank, right? And they do development that way. And then next is coming hybrid cloud, Azure Arc, right? A lot of things in Azure are actually containerized. And so when Azure Arc comes out, it is going to give you the ability to run Azure data services on premises, on your own infrastructure. But you will have to have the ability to run containers and the knowledge to leverage some containerized data in order to do that. And that's a really interesting concept, because, you know, we heard, you know, a couple years ago that, you know, the data center was dead and everybody was going to the cloud. And then we figured out some things work better on the cloud, and some things work better on premises. And so there was a balancing in between. And then we run into issues with developers building things in the cloud. You know, maybe development is good up in the cloud. We're going to run our production environment on premises. And then we find out what they built in the cloud doesn't work quite the same way as on premises. So this is helping give that, bridge that gap, right? Because I think everybody's now looking for technologies to move to hybrid environments, right? It's not a either or, it's a both. And we need them to now is it not just a both, but for this one application and this other application, but it's both, and we need applications to move seamlessly to them. So Microsoft introducing Azure Arc, which is supposed to be released, I think, April 9th this year, is the next step into that. So containers are coming, right? And I give the, Bob Ward said for you, everybody to use this. He loved the slide, so I include it because I actually love the slide too, right? One of the things that's interesting that why databases weren't included into a lot of containerized environments when they started going out was the problem of persistent storage behind the database, right? when you spin up and containerize databases, when you get rid of that container, everything goes away. So you have to use persistent storage behind a container environment. Maybe one of the reasons why I'm passionate about them, because it was, I work for a storage company, so you have to leverage storage strategies. I think if you're going to do a containerized environment, but what we can do with them is amazing, right? And they're so lightweight. Consistent images. I don't know how many of you guys spend a lot of time trying to make sure that your database environments were consistently deployed, right? But when you do containerized images, and we'll talk about that in a minute, that really kind of addresses that issue. And then maybe you just have to make sure that people, while they're up and running, don't fall out of that consistent image that you set up, right? Because people still can make changes, but there's a lot of technology coming now to make that change. And then, yeah, the reduced patching, which we've already talked about. But storage strategies are something you really need to think about, right? Because when you spin up a container, right, it spins up in just like a millisecond. But then when I was first watching these, when they came out, when people started talking about this 2 years ago, they were like, now do a restore of your data set to this database. I'm like, well, that's not fast, right? If you have a large database, that can take a long time. So when you look at some of the storage technologies that come out, there's a lot of cloning technologies and things that most of the modern storage, actually all of the modern storage vendors can do, right? They've been out for like 20 something years, and I've leveraged them for most of my career. But I will say historically, unless you work for a really large enterprise company, you didn't get to do it because it was very expensive. It was in the tens of millions of dollars, and they were very complex to set up. That has changed, right? So most storage vendors include the software now with what they do. And even before I came to work for a storage company, I was advocating that DBAs know about what they can do with this kind of technology, because it does become a game changer, right? I was doing this way before Pure was founded. So the fact that you can present clones of data into databases really quickly becomes a game changer. And when you can redeploy those entire SQL Server environments really quickly, it's really nice, right? And then a lot of these new cloning technologies that people have out there, right? There's, software vendors that do it, and then there's storage companies that do it. You can now mount multiple copies of your data when you do it right without consuming extra space. And that's really also a game changer, because now not the container is negating the compute cost for you, and then some of these other technologies are negating the storage costs. So now they're making this dream that we've all had of everybody having their own environment really cost effective, right? I tried different ways of doing this when I was a DBA. We were going to do our dev test and UAT. Those were full copies of data sets, but down in some, we wanted to have what was a pre-test environment, right? There were more of those for the developers. And we wanted those to have smaller data sets because storage was expensive. But what we were, the challenge that we faced was one of the things we looked at doing was just scrubbing the data out and removing sets of data, right? So that they had a scaled down data set. But there were a couple of problems with that. One, we were agile shop. We had about 250 data point changes a week, which means about 250 changes were going to have to be made to that script a week. Also, within our data set, there were also lots of variation within the data that affected our code that we would have to account for when scrubbing that data, right? So it wasn't just, which columns we were including and how many records, but maybe, we wanted, customers in every state, all 50 states. And then we might want some in this time zone in Indiana and that time zone in Indiana, because Indiana's time zones vary by county, right? So you want to make sure some functionality works that way. So those were a little bit problematic. It was something we kind of quickly abandoned. And so what we went with for these lower environments was that we started stubbing out synthetic data set. It became every developer who created a new data point, their responsibility to create this stubbed out synthetic data set. So the problem with that was, one, again, they didn't hit the bugs that they should hit right away because they didn't have full data sets. But the quality of that was only as good as the amount of effort of time that each developer was wanting to put into it. And, so it depended, right? At least now at this point, we were scaling out the work that had to be done, but some of the developers really didn't care. And so, things would pass QA and UAT testing. And then we would figure out when we would go through our automated regression test to figure out why it worked, because we might be looking for an error to pop up from a data set. We figured out that they hadn't actually stubbed in any data. So that was problematic. So that is why I like leveraging storage strategies with containers. All right, so on. And do feel free to ask questions if you have them. So let's talk about spinning up a basic container. This is the basic container command. It's a Docker pull, right? The Microsoft /MS SQL Server Windows -developer. It's a really common one that you see. That's what you're going to do to pull the image. If you're going to be doing demos with this, the developer is the free edition that you can use. It's great. Don't use it in your demos. I did this last year because it is changing all the time, and that is beta. And so you can get a bad image. So when you're doing this in production, right, you're going to have a named version that you're pulling down so that you know which version it is. But this is when you run that pull, that's going to download the image for you to use. And then to install it, all you have to do is a Docker container run. And there's a couple commands in here at the end of this that you see. There's the -G that's saying we're going to go back to this, right? You're going to run that service as a background. The -P is for the port number, right? That's really important that you know what port number this is going to run on, because you're going to have to use that to connect to that container. --name, right? You're also going to need this to connect to the container. You can actually just do the Docker container run with the accept EULA, and it will install it. It's going to have a really funky name, which can be fun to actually go in and look at your container environment and see what names it came up with. But if you want to be able to log into it, you're going to have to give it the SA password and the name, and make sure you know how to log into that. So don't forget to do that. But basic, it's pretty easy. Also, some issues if you start playing around with these. I also listed all the different run options that you can add, because there's tons of different parameters that you can add on here when you start automating these. But when you start playing with these, it's probably maybe better to play with this in a Linux environment. You can download them and run them on your desktop. But when you start trying to spin up multiple containers when you're on a Windows environment, sometimes you run into this port issue right here where you can't, and I couldn't figure it out for the longest time until somebody told me what was going on, because I could get them to run on my Mac and I could get them to run on my Linux box, but whenever I tried to spin one of these up with the Docker software on my Windows boxes, I was getting into this port virtualization issue, right, where they couldn't give me more than, I couldn't connect to more than one container at a time. So just be aware of that. That's why most people are doing Linux-based containers, right? So that is the basics for running up a container. So I wanted to show you how quick it is, right? So we're going to go through doing this in my environment. So this is my lab that I've got running up here. And the first thing I'm going to do is run a ps-a, which lists all the Docker containers that are running in my environment. So you can see that I'm actually not running anything. And then after I do that, I'm actually going to pull down the latest edition of the Windows Developer. And then I'm going to run the Docker run command so that you can see that I've got that container up there running, and it's been running up there for a few seconds, right? It just took 3 seconds to actually download the image and install that SQL Server. And so now you go in here, now that I've got that password and I know the name of that instance, I can go out here and connect. But you can see it's just a blank SQL Server instance. There's no data in it. So now what I'm going to do is I'm actually going to show you that I don't have the FT demo database because nothing was done. I just like to show that it didn't really exist. And now I'm going to create the FT demo database. And once I create that database, I'm going to be able to create my guinea pig table and insert some data. So now that you see that I have that out there, right? I'm going to show you that there's some data within the table. I should actually scroll out to do that so you can see that, because there's a lot more data there. And now what I'm going to do is go in here. I'm going to tear down the container. So the first thing I have to do before I get rid of my container is I have to stop the container. And then once I stop the container, right, you can see that it stopped. Oh, sorry. Let's do this. We're going to stop the container and then let's start it back up. And I just want to show you that just because you stop a container, when you start that container up, the data is still going to be in there, right? So you didn't lose the information in the database because you stopped the container. But when you do this, you stop the container and then remove the container, right? When you go back and redeploy that same container, none of that data is in there anymore, right? So now we're redeploying and we'll go connect back to our environment. And as you can see, I've now lost all that data because that was only persistent to that container that was in there. So it doesn't matter that I redeployed it with the same name. So that's why you want to leverage something sitting in the storage outside of the container so that you can keep any data that you created, right? So let's do the next one. So this is where you're going to use a mounted volume. So I should change this, hold on. With the mounted volume. This is what the mounted volume code is going to look like, but let's go through it. And I'll show you in a second. So I just want you to be aware that's out there. Oop. Let me get that to go back in. So we're now back into the same SQL Server environment, right? Let's look and see what we've got out here. We've got no databases in that environment. So now what I'm going to go do, this is actually going to go connect to my production environment. I just wanted to show you this, that I'm going to go get a copy of my production data, my database really quick, and copy it, leveraging my storage, right? And that's just how I do it. So several PowerShell commands that I'm running to go do that. And once I do that, I'm going to take a copy of that and now present it over into my container. So this is the command that you have to run. It's an attached DBS, and you list all of the share locations right up there, see at the top in the variable, into a shared data folder. I'm sitting there listing that. Right, so I've got it sitting on a single volume, and I've got that in a variable. And then this SQL Server command that we ran earlier where we deployed a new container, at the end of it, you just use a -- mount and you tell it to bind a source, and then you give it the name of that source, which is the shared data, and then the variable that you've created up at the top. And these will be available for you guys to see afterwards, and I will also give you guys a copy of the presentation so you can get the code that does that. So that's all it takes to mount a container once you do that. And what's really interesting, I like to show this, how much data did I move into that container? You saw me in just a few seconds spin up a 3.2 terabyte database, right? I deployed the database and I put 3.2 terabytes of data in that in just a couple of seconds. So that, I think, is what, when we talk about agile development and redeploying these databases over again, becomes really important. Because when you're doing these CI/CD pipelines, think about your roll forward and your rollback scripts. A lot of times when you're pushing code forward, right, you can't just push forward like they can with the application developers. You have to undo your changes. And if you didn't have a good undo script, more than likely you have broken your database environment so that you're jeopardizing actually the testing of future roll forward scripts. So it's really a good idea to refresh that data set as much as you can so that you can assure the code works. Because what I've seen a lot is like people mess around with stuff. They're like, oh, well, I didn't realize I didn't have this in my environment. So they've got their script, but they're fixing things. And then it goes to production. And then they're still fixing things because production and test dev didn't match. And they didn't include everything in their script. So when you refresh these databases all the time, you are ensuring that people haven't manually added stuff to the system, right, that they forgot to update in their scripts. So this was, again, the code that we used in there, right? You can see the huge attached DBS statement right here. I tried to blow it up so that everybody can see it. And we just list out all the different kind of files that we have in our database. And this one had in particular a lot, right? And then here you can see at the end of what we had was the accept EULA before, we just do this -- mount. We're telling it to bind. We give it a source drive, which is our f:\data, right? That's what the source is, and this is the target of where it's going to within that containerized environment. And if you can hear my dog, I'm really sorry about that. So also a couple things for you guys to know. I want you to know some useful resources if you want to start playing around with containers. Microsoft has got a great quick start guide. I'm listing out the container image pool again, just so you have that. I've got the run command for a container. And I should probably put the other commands in here. So I've got a couple of the run commands in here. But then when you want to see what you have up and running, the ps-a, right, the docker stop, those are all helpful. So now what we're going to do is like look at this containerized and database environment again, right? So let's take a look at it and see what happens when we do some stuff with this, right? So I don't have any current containers or databases in my environment. So now we're going to redeploy our container with the shared data in here that we've copied over from our production environment. And as you can see, we've got the FT demo database again. We've got some tables in here, but we don't have our guinea pig table. So now what we're going to do, well, before I do this, let me show you how big kind of this database is. Again, I just wanted you to confirm that this is the large database. It's about 3.2 terabytes, right? So now that we can see we don't have the guinea pig table in there, right? And I'll just run this select statement so you can see that. Oh, no, let's go over here first. Let's create the guinea pig table. And we just inserted some rows into there. And now we're going to select some days so that you can actually see that I've put data into that table. And now let's go back. Let's refresh real quick and show you the guinea pig table that it's sitting in that database. And now let's go back and do the same kind of thing that we did earlier. Now that we've got that attached database, we're going to go ahead and remove the container, right? We're going to stop it, the docker stop SQL 01 and the docker rm SQL 01. And now we're going to run a ps-a to list all of our containerized environments out there. And you can see when we run this, we don't have any other containers running in our environment. And now let's reattach that same container with that persistent database sitting outside of it. And when we go back in here and we refresh this, you can see that my guinea pig table is still there. So I still have all the data that I added to my clone, right? And everything is in there and I haven't lost anything. Just kind of highlight again why it's really important to use that persistent data outside the storage. So let's talk about some terminology when you're going to be using containers. Host, right? That is going to be, think of it as your ESX host that you have in a VMware environment. It is going to be the host where your container physically sits. And this can be a physical machine or it can be a virtual machine. It can be a Windows machine or it can be a Linux machine, though 99% of the time it's going to be a Linux machine. Container engine is the service that you interact with to build, deploy, or run your containers, right? So we'll get into some examples of what these are in a minute. Your repository is going to contain all the list of images, right? That is basically the SQL server that you're installing and running. And images, right? Those are not only there are the different versions, right? So you can have a SQL Server 2000 image, a SQL Server 2017 image. I guess you can have SQL Server 2000 image, but you can have a SQL Server 2017 image, a SQL Server 2019 image. But let's say, for example, and I'm just going to use this, have you ever run an imaging database? Maybe your default settings for all your databases that you have in your container images is that you have a max stop of 0. But now you've got to have a particular instance that you need to run for your imaging servers. And most imaging servers will require that you have a max DOP of 1. So now you're going to build a new container image that's for your imaging servers, and you actually change the setting in that image. So when you redeploy from that image, right, everything's always set with a max DOP of 1. That's how you can get consistency in your database environments, right? So let's talk about this engine, right? For SQL Server, there are quite a few Docker engines, container engines out there, but when you're talking about SQL Server, it's really only Docker. Now, you do hear people debate whether or not they're going to use Kubernetes or Docker, but that is not really the engine that they're debating about using. It is one of the container orchestration tools. And container orchestration tools are what balance which host your container is running on. They are balancing the containers between the resources that they sit on. And so I listed out some of the most common ones, right? Again, Docker and Kubernetes are probably the two that you hear people talk about a lot. OpenShift, right? So if you don't want to have something that's open source, most people are going to be going with Red Hat OpenShift. Mesos is the one that is picking up some movement. Windocs I listed in there because if you're going to do Windows containers, I think that's really the option that people are going to. But my other favorite one, right? So I'm a big fan, Docker, Swarm, Kubernetes, OpenShift, but Rancher, right? If you're going to play around with this in your environment and set this up, and you are not a Kubernetes container expert, I suggest you play around with Rancher. Rancher used to give you the option of running the Swarm orchestration engine or the Kubernetes engine underneath. So Rancher is an orchestration engine, but what it's done is it's automated a lot of the setup for you. But now, because Docker Swarm is now kind of gone away and it's now only Docker Enterprise, I think, which is a paid-for version, so I probably should update this a little bit, but I just leave it out there so that people know. Now it runs with Kubernetes underneath, and so it's just super easy to set up. Kubernetes is probably predominantly the largest one that's used out there, but if you're a DBA, you'll probably find it a little bit hard to set up. You really need to be kind of a Linux container person in order to easily set up Kubernetes. So just throwing out there. Application managers, what are they? So these are terms that you're going to hear when you have all your container images out there, right? And you need a repository for them to sit in. This is where this is what's going to hold those images. So they're going to sit in something like ARM or AMI, which is Amazon Machine Image, or Keel. And I don't know if I cleared about this, but these container orchestration tools, they balance where your containers sit. They don't deploy your containers, right? They're just kind of the load balancer of how the containers run. That is what they do. They monitor them for resources and not much else. So containers are also kind of interesting because there is a lot of, pick and choose your own. It is definitely the best of breed, so you can pick which, components you like and mix and match them all. So then this is where it becomes kind of interesting when I was like getting into containers and starting to look it all up, like as I was in my Rancher environment. I'm like, where do I schedule my automated deployments in here? I'm like, what do you mean they don't do that within here? So when you are going to schedule the spinning up or the automation of your container environment, a lot of people are now starting to leverage, where before they were just maybe doing it from the application, they're really leveraging infrastructure orchestration tools to do this, right? So you'll see things like Puppet and Chef, or infrastructure orchestration tools that people use in the past. They use them for bare metal machines. They use them for VMs, because they can also do those same kind of checks that we do as DBAs, maybe to make sure that the host OS are always configured the same. These tools can also do that. So the next evolution of that is probably SaltStack and maybe more commonly Terraform, that people are moving in to do this. So they can do legacy hardware, but they also can do the container orchestration deployment, right? And automate that infrastructure as code. And that's, I think, is it kind of interesting to use a unified something to do that, because we all want our, one of the things I looked at was that there's a lot of things I want to run in common between my VM environment, my bare metal machines, and also my container environments, right? There's a lot of common settings, and we used to have to code things per stack, and then we were looking at moving things to more common coding, so that we had something that affected all stacks the same way, so we had less tweaking to for each individual stack. Jenkins and Ansible I have as somewhere in the middle between infrastructure orchestration and application orchestration. I think they're more applications orchestration centric, but they can also do infrastructure orchestration. So I think a lot of people kind of started with Ansible and Jenkins in this, and now they may use it for just one portion and then the others for their infrastructure orchestration. But then when you look at application orchestration, right, you've got things like, you know, a long time ago, people were just using Subversion and Visual Studio. And then I would say Redgate probably got into the game, and then GitHub. And then now you're saying, and Jira. Jira was around a long time too, right? And then now Azure is getting into that, and CloudBees. So those are all your application orchestrations, so that once you deploy that database, you can automate that code like you saw me doing earlier, where I was inserting the guinea pig table, right? So those code deployments can be automated after that. So I've got this up here. I wanted to see if anybody had any questions so far. This is usually a 90-minute demo or talk. And so I usually kind of stop it right about here instead of getting into it. But I wanted to be clear that you're not like, so when you're playing around with these containers, the command line is for you to kind of understand how they work. That is not how it's going to be deployed in your environment, right? You're going to be working with a team, and they're going to be leveraging these tools like Rancher and Kubernetes and Docker and Terraform. And so you need to understand what these different things are in your environment and what they're doing. And I actually did set it up in my environment, but I don't know if we can get into it in an hour. So where we were spinning up lots and lots of different containers and clones.
Hi, Marsha. So there's no questions, but someone did ask if you could please share your GitHub repo.
I will.
Okay, great.
I'll put that with everything out when I publish these slides.
Okay, great.
So
Thank you. Awesome.
All right. Well, that was all I had for you guys today. Again, this will be published afterwards, so you will be able to download it from the website, and I will pull together some of the code and the GitHub repo as well.
We just got a couple questions.
Okay.
How does SQL perform in container compared to VM?
To VM? So we're still doing a lot of testing on that. I haven't heard of I don't think high speed end-to-end testing, I don't think from what I've seen that the containers quite beat Windows-based machines yet, the Linux do, right? They're getting really close. And I think there's just a couple things that I'm aware of that people are waiting on, because the idea, or at least when I heard of SQL Server running on Linux, and eventually it's going to be faster, because there are a lot of limitations on the SQL Server side that are actually, I think, based on from my opinion, right, just my opinion, that are based on the Windows OS. So I think once we get a couple things out of the way, as far as the controllers and stuff that they're leveraging to talk underneath, my company's been doing some testing on this, I think the speed is going to dramatically improve. But I would say for most use cases, they're on par. People are starting to deploy these for limited use cases in their production environment. So trying to think of things that I have seen people deploy them to. We were joking about this actually on the Redmond, Washington call. Like, for really small databases that you don't want to have to manage a VM for. So I've seen some people try to play around them for things like, if you've ever had to manage a Kofax database, right? These vendor applications that, like, they'll want you to install one tiny little database that has to be managed. Maybe putting that on a container could be an interesting conversation of going some places. I've also seen people use these when it comes to production workloads for managing some streaming data. They've started to do some testing that's coming in where they don't really have to worry about every single application, but we're advancing really quickly with the features that have come out. Like last year they came out with availability groups, right? So that was the big hurdle before, was high availability. So I think it's just really getting people comfortable with them. But you are going to see, I have I would expect a lot heavier within the next year and a half, 18 months. You're going to see more people deploying databases into containerized environments. I think the adoption is going to be much quicker than it was with virtual environments. And for that matter, even VMware, right? So when we talk about this, most containers run actually on VMware. And now VMware is coming out with its own containerized database, which I haven't got to test with that one. Some other people on my team are testing that one and playing around with it. But I think that's going to be really interesting. And the fact that this gives you this like portability interesting between cloud and on-prem. What other questions do we have? I'm not seeing the questions.
Okay. If experimenting with different infrastructure application orchestration, are there Docker containers with different combos?
Okay, I didn't understand that.
If experimenting with different infra/app orchestration, are there Docker containers with different combos?
So it's all going to be Docker, right? But yes, you can do different combos. So like you can mix and match any of these. You can, right? So if the question is, and tell me, please type in if I'm not answering this, can you use Terraform with CloudBees or Terraform with Jira or Terraform with Redgate? Absolutely. It's a mix and match. It's separating out what you do. Now, if you're going to use Terraform and Jenkins, you do want to separate out which one is going to be deploying your environment versus which one is going to be doing the code updates. But yes, people mix and match these all the time. And I've seen lots of people with Jenkins and Terraform.
Okay, great. Does Pure Storage offer SQL data obfuscation with their SQL cloning offering?
No. So we have some scripts out there to do that. I have opinions on data obfuscation. So I would think that if you're going to do, I think Redgate does that. IBM does that. That people have, and I've looked at different tools to do it. And I was talking to somebody else actually just this week about data obfuscation. I don't think, in my personal opinion, that most tools do it well. And the reason why they don't do it well is not because the coders aren't smart and they can't figure out how to do things. It's because DBAs are terrible people sometimes, and we let bad code go into our environments. So the problem that I have seen with the obfuscation tools, and I've been looking at obfuscation since, again, like about 2006, right? That was when we started playing around with it and started leveraging it for getting code down to some of our lower environments, was that when everything I've ever looked at relied on something automated for the most part to make this easy, right? When they give you the demo, they're going to show you that, you put in and it's going to automatically detect social security numbers and it's going to like obfuscate them the same way. Well, it requires the DBA one to define where social security number sets, right? And then let's hope because not all DBAs know their data set that well. They tend to be kind of broad, and the larger your environment, the harder it is. This is where data architects are becoming more and more important, not database architects, but data architects, right? Who are defining where your data sets. But then let's hope that social security number is defined in the same way everywhere, because some people may be storing it as an int, some people may be storing it as a bar chart, and some people could be storing it as text and others in varchars. And their algorithms that they use for obfuscating data usually depend on the data type. So while there are automated ones that would do it and they would try to detect things, most of the environments that I inherited when I would go look at our code, and we bought some of these tools, they were so complex that we ended up, it required my DBAs almost manually defining anyway, that we just ran our own obfuscation scripts. So every time I look at a tool, and I've talked to people, does it work in your environment? And I was talking to a company I know the other day because this question came up again because I was trying to figure out if some changes had come. And this one company I know, I think runs one of the cleanest data sets around. I was like, have you gotten across the issue of people having different data types for the same data in different areas of your business? And they were like, no, still a problem, and we just gave up on it because we couldn't get them to agree. So, right, so you may have, let's say, your accounting team doing development, and then you have your marketing team doing development, and they've got their own set of developers, and they're arguing about how the data is going to be stored, and they both have some duplicate data in their system, and they're not going to work in the same way. So that's kind of the problem, right? And so I hope that answers your questions, but you can obfuscate data, but Chris Atkins, who is my counterpart for EMEA at Pure, wrote a script that you can use that will use some stuff to obfuscate it. You can look at a tool to do it as well, but just realize even if and tools can be useful because you can use some of their algorithms to obfuscate data, but I think you're gonna have to end up doing most of the data definition, defining yourself, if that makes sense.
Okay, great. We have got some more questions. Lots of possible environment combinations. Exactly. Are there pre-configured images in the wild?
Wait, answer the question one more time. Ask the question one more time.
He said lots of possible environment combinations. Exactly. Are there pre-configured images in the wild?
Well, so images would be something else. So let's go back to images. Like, are there pre-configured when we're talking about the SQL Server images for the application managers? Yes. And there are some that do some better. So Windots tries, which is Windows-based containers, tries to do a lot of that all in one. Rancher, again, takes the Docker and the Kubernetes portion of that and some other things, and it's kind of doing an overall, it's combining some more functionality in there so that it's a little bit easier to do. It doesn't do the scheduler. Ansible and Jenkins can kind of cross this platform and do both of these, right? So it can do infrastructure orchestration and application orchestration. I think it's just a little bit easier. Well, so is there a unified, or has somebody come up with a good, is Terraform working with Redgate? I don't think so. I think most of these people are in the open source movement. I would have to go look and see. And I think it's kind of a pick your own, but there are ones that are considered industry kind of standards now. I would say in the container, I hear lots of people doing Terraform. That's the one. Like Puppet and Chef were what I heard of historically. Terraform for infrastructure is where I hear people going. And then this is kind of, this application orchestration is a religion for people. They have what they like. I was a Subversion girl. I liked Subversion, and I did a lot of my role, and I used Subversion and some Redgate stuff to kind of automate my deployments. But I was doing it also a lot before a lot of that. Ansible is where I hear a lot of people going now. So most people I know are doing Ansible and Terraform and Keel with Kubernetes. That is the combination I hear of most, or OpenShift.
Okay, great. Different combos of containers, infrastructure, application orchestration. Since there are so many combos, what would you recommend as best practice?
What there? I think I just gave it. Those are the most common ones.
Okay.
Yeah.
All right, great.
And if you're going to play around with them, again, use Rancher. That's going to be much easier. But yeah, you don't want to go with something too off the wall, but also you have to look and see what are you doing in your environment? What do you guys already have? If you guys are already a Visual Studio shop, then use Visual Studio. That's in your wheelhouse. So you want to look at the skill set of your team a little bit, right? If you're a Redgate shop, keep using that, right? So there are certain things that you can do, right? You do want to limit, or at least I always tried when I ran these shops to limit the amount of software we used and the amount of code we were learning, because, what does that say? I'm trying to think of it. Oh, it's something and master of none, right? You know a little bit about everything and you're the master of nothing, which may be me right now. But, if I would watch my developers like, we're going to do CLR development. We're going to do this. We're going to get down and try to do, I'm trying to think, they did CR development, which they would try to do these DLLs and encode some stuff in DLLs. And I'm like, no, I don't want to do that because I want something that everybody can troubleshoot, everybody can take a look at, that everybody has a skill set in, right? So it was also, I was trying to limit the number of databases my group managed because like the developers would like just create stuff and then try to throw it out to production. And, one week they were using MongoDB, and then the next week they hated MongoDB, and now we were using something else, and so that they could never keep it in their mind. And I was like, I can't have DBAs be expert in 30 different database platforms. We need to pick a few. So that was my opinion. What else we got?
I think that's it.
All right. Well, I enjoyed talking to everybody today, and I think we're wrapping up right on time.
Yeah, great. Really great presentation. Thank you so much, Marsha.
Thank you very much. And I hope everybody has a great Saturday. It is pretty out today. Hopefully it is where you live.
Yeah, it is here in Southern California for sure.
Yeah.
All right. Thank you so much, everybody, for joining us. We really appreciate it.